Welcome to all of you. Today we discuss on difference equation and stability of equilibria of a difference equation, first order difference equation, either nonlinear or linear. So first we discuss uh, what is difference equation and the different types of difference equation. And consider the sequence xt. This t runs from 0 to infinity, x0, x1, x2, xn, non-negative integers n, where xt equal to some function of t, ft. T is time variable, time parameter, a function of time t, and non-negative integral variable t. A difference equation of order k has the form xt plus k plus a1 xt plus k minus 1 plus a2 xt plus k minus 2 and so on, plus ak xt equal to b. And this is the difference equation of order k. Order k, here maximum suffix is t plus k and the lowest suffix is xt. So t plus k minus t, that is equal to k. So the order of this difference equation is k. Here a1, a2, ak minus 1, ak and b are all constants. And note that here the constant ak must be not equal to 0. And t runs from 0, 1, 2, to infinity. And a1, a2, ak, they are constants or function of t. Okay, function of t. Now, this difference equation 1 is said to be autonomous difference equation if it does not contain the time t explicitly. Otherwise, it is called non-autonomous difference equation. The order of the difference equation between the highest and the lowest suffixes is the order of the difference equation. So here t, k plus 1 is the highest suffix and t is the lowest suffix of x. So difference between these t plus k minus t k is the order of the difference equation. And linear, non-linear, if the coefficients a1, a2, ak are constants or depend on the independent variable t, but not on xt, then the difference equation 1 is said to be linear difference equation. Otherwise, it is non-linear difference equation. So, power of xt, power of the term xt or xt plus k or xt plus 1 are all of 1, power of 1. If except other than 1, then this difference equation is nonlinear. So multiplication xt into xt plus 1 is nonlinear, and xt to the power half nonlinear term. So the difference equation is nonlinear, then nonlinear. Now homogeneous, if the right hand side constant coefficient b may be constant or function of t, then the difference equation of 1 is said to be homogeneous. Otherwise, it is non-homogeneous. It will be not equal to 0, then it is non-homogeneous. Consider an example, xt plus 2 equal to a xt plus 1 plus bxt. Here a, b are non-zero constant, and equation 2 can be written as xt plus 2 minus a xt plus 1 minus bxt. Here the difference between the highest and the lowest suffixes, that is t plus 2 and t, so difference is 2, so its order is 2. And the constant term is equal to 0, obviously the right hand side here is 0, so it is homogeneous equation. And equation 2 does not contain t explicitly, so it is autonomous equation. All coefficients are constants, that is there is no term like xt square or xt into xt plus 1, so it is linear equation. So the equation 2 is a second order linear homogeneous autonomous difference equation. Consider the next example, xt plus 1 equal to a into txt plus bt square xt xt square xt minus 1 plus cos t. Here we are non-zero constant quantity and quantities, and since here the maximum suffix is t plus 1 and the minimum suffix is t minus 1, so difference t plus 1 minus t minus 1 is 2, so the order of this difference equation is 2, and it contains t explicitly because here a into t and pt square and cos t term are present here, so it is non-autonomous system. And uh, if we write this expression in this way, xt plus 1 minus at xt minus bt square xt minus 1 equal to cos t, then the right hand side the term is cos t, so it is non-homogeneous difference equation. And there is the term cos t, it is not homogeneous, and like there is no term like xt square or xt into xt plus 1 etc., so it is linear equation. All xt, xt plus 1, xt minus 1 are present here with power 1. So this difference equation is second order linear non-homogeneous non-autonomous difference equation. Next. Now, what is the relation between differential equation and difference equation? Consider same simple example, dx dt equal to gx with the initial condition x t equal to 0 equal to x0. This is the differential equation dx dt equal to gx. It is, if it is not possible to find a closed form solution of 1, we may apply numerical method to find approximate solution of 1. In Euler algorithm, for example, we start a point t0, t1, tn, so on with h step length h equal to tn minus n plus 1 minus tn as the step size. Then t0 less than t plus 1, we approximate xt by xtn or xn, and dx dt by dx dt equal to xn plus 1 minus xn by h. So differential equation 1 can be written as x n plus 1 minus xn by h equal to gxn, and so we write xn plus 1 equal to xn plus h into gxn. This equation 2, with the help of this difference equation, we can generate the values x1, x2, xn, so on, and these values gives the approximate solution of the differential equation 1 at the grid points t equal to 1, t equal to 2, t equal to n, that is at t equal to t1, t2, tn, provided h is sufficiently small. So we can replace the difference equation 2 with the differential equation 1. So this is the relation between differential equation and difference equation. Now we considered a first order constant coefficients linear homogeneous difference equation. So this is the simplest difference equation xt plus 1 equal to axt with the initial condition xt equal to 0 equal to x0 and the constant a not equal to 0, and find its solution and mention the condition of convergence of the solution. Here xt plus 1 equal to axt with the initial condition xt equal to x0, x suffix 0 and a not equal to 0. And putting t equal to 0, 1, 2, n in 1 successively, we get x1 equal to ax0, x2 equal to ax1 equal to a value of x1 is ax0, so put here ax0, this is equal to a square x0, and so on. And lastly, we get xn equal to axn minus 1 and equal to this similarly x2 equal to a square x0, so xn equal to e to the power x0. Hence, for any t, we can get the value of xt equal to a to the power t x0, and this is the required solution of the difference equation 1. The first order constant coefficient linear homogeneous difference equation, this one. Now if the constant a modulus value of constant a is less than 1, that is if minus 1 less than a less than 1, that is a not equal to 0, then obviously this limit t tends to plus infinity a to the power t obviously equal to 0, and so xt from the equation 2, xt obviously equal to 0, and so xt converges to its equilibrium value 0 over the time. And so equilibrium point x equal to 0 is stable. And case 2, if modulus a is greater than 1, that is if a is less than -1 or a is greater than 1, then limit t tends to plus infinity a to the power t equal to either plus infinity or tends to minus infinity. When a is greater than 1, we get this limiting value is plus infinity, and when a is negative less than 1, and then the limiting value tends to minus infinity. So limit x tends to so t tends to plus infinity, x equal to plus minus infinity, and the solution diverges. Obviously, in this case, the equilibrium point x equal to 0 is unstable. And case 3, if a equal to 1, then this a equal to 1, and then equation is this xt equal to xt plus 1 equal to xt. Here a equal to 1, so xt plus 1 equal to xt. So in third case is a equal to 1, then limit t tends to infinity, x equal to x0. So xt converges to its initial value x0, which is equilibrium value for this case. So x0 is stable here. So all values xt plus 1 equal to xt equal to dot 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 equal to x0. And case 4, if a equal to -1, then xn equal to -1 to the power 2n x0 equal to x0, and x2n plus 1 equal to this equal to minus x0. So xt oscillates between x0 and minus x0. So here the condition of convergence, clearly this -1 less than a less than equal to 1 and a not equal to 0. And this is for 1 equal to we get the value x0, stable equilibrium point x0. So condition is -1 less than a less than equal to 1, and then the difference equation 1 xt plus 1 equal to axt is convergent with converges to x0. Uh, Later we will discuss the equilibrium point of the one. If we put x equal to x star be an equilibrium point, then x star equal to a x star. X star here if x star equal to x star is equilibrium point, then xt plus 1 equal to xt equal to x star. So we put xt plus 1 equal to xt equal to x star equal to x star equal to a x star. So we get x star equal to 0 when a not equal to 1. If a equal to 1, the system 1 becomes xt plus 1 equal to xt, and clearly x0 equal to x1 equal to x2 equal to x3 and so on. So he shows that initial value x0 is the equilibrium value and x star equal to x0. Next, consider first order constant coefficient linear non-homogeneous differential equation. Here extra term is plus b, so it is non-homogeneous difference equation. Only difference on from the first equation and first difference equation is b is not present there, and here plus b not equal to 0. This is the first order constant coefficient linear non-homogeneous difference equation. With the initial condition xt0 equal to x0, find its solution and discuss the stability of solution, and hence deduce the solution of the corresponding homogeneous case, and transform the above equation to its corresponding homogeneous equation, and then find its solution. First we put xt plus 1 equal to axt plus b, put t equal to 0, 1, 2, n in the given equation. We get x1 equal to ax0 plus b, x2 equal to, and simplification, after simplification, a square x0 plus 1 plus a into b, x3 equal to a cube x0 plus 1 plus a square into b. So ultimately we get a xn equal to a to the power n x0, 1 plus a plus a square plus dot dot plus a to the power n minus 1 into b. So this is the series, finite series, this a 1 minus a to the power n by 1 minus a, when a not equal to 0, the value of this 1 plus a square plus a to the power n minus 1, we get this. So a n common, take common a n, this x0 minus b by 1 minus a, plus b by 1 minus a. And here this b by 1 minus a, and common b by a minus a to the power n, so take common minus 1 minus a to the power n, so b by 1 minus a not equal to 0. Hence xt equal to, we replace t in place of n, so t equal to a to the power t x0 minus b by 1 minus a plus b by 1 minus a, where a not equal to 1. This is the solution of 1. If a equal to 1, then from 2, equation 2, and this the solution xn equal to a to the power n x0 1 plus a square plus a to the power n minus 1 into b. So put here a equal to 1 here, put a equal to 1 here, we get xn equal to x0 plus nb, because here 1 plus 1 plus 1 plus 1 plus 1, so here in terms in ones, so we get n into b, and this solution is this xn equal to x0 plus nb. So for any t, put t in place of n, so xt equal to x0 plus t into b. This is the solution when a equal to 1. If we put b equal to 0, we get the homogeneous equation xt plus 1 equal to axt. And obviously, I already discussed this case. The solution of this homogeneous equation is given by xt equal to a to the power t x0, and putting b equal to 0 in the 3. You can deduce from equation 3, this equation 3, put a equal to a, b equal to 0, put here b equal to 0, so a xt equal to a to the power t x0. If a equal to 1 and b equal to 0, then obviously we get xt plus 1 equal to xt, and then x0 is the initial value, x0 is the equilibrium value, x star equilibrium point, and this equilibrium point x star, and we can find equilibrium point x star by putting xt plus 1 equal to xt equal to x star, and the given equation putting this value xt plus 1 equal to xt plus a equal to x star, so x star equal to a x star plus b, so x star equal to b by 1 minus a. So this is the equilibrium point when a not equal to 0 for the given difference equation. This a xt plus 1 equal to a xt plus b. This is the for this difference equation, the equilibrium point is this x star equal to b by 1 minus a not equal to 1. If a equal to 1, then x star equal to x0. Now we transform this non-homogeneous given equation, this xt plus 1 equal to axt plus b into corresponding homogeneous equation. So for this, we put a new variable yt equal to xt minus x star, where x star is the equilibrium point of the system. So this xt minus b by 1 minus a not equal to 1. So xt equal to yt plus b by 1 minus a, and then obviously xt plus 1 equal to a into xt plus b, and so the given difference equation becomes in terms of yt plus 1 plus b by 1 minus a equal to this given difference equation is this, so put here xt plus 1, so yt plus 1 plus b by 1 minus a, and a into yt plus b by 1 minus a. Actually, we put here in t in place t plus 1 in place of t. So xt plus 1 equal to yt plus 1 plus b by 1 minus a. So put here xt equal to this, and xt plus 1 equal to this, and xt equal to this. So after simplification, you get yt plus 1 equal to a yt. And there is no constant term here. So this is obviously this is the homogeneous equation, first order homogeneous equation. This solution of this system is yt equal to a to the power t y0, and here again put the value of yt xt minus b by 1 minus a, and y0 solution of the corresponding homogeneous difference equation. Now the stability of the solution and the difference equation is xt plus 1 equal to axt plus b not equal to 1, and we have the solution this type xt equal to a to the power t x0 minus b by 1 minus a plus b by 1 minus a. Case 1, if minus 1 less than 1 less than 1. So a not equal to 1, that is mod of a less than 1. So we get limit t tends to infinity xt equal to this. So obviously t tends to infinity, e to the power t equal tends to 0. So we get b by 1 minus a, that is equal to x star. So with increasing time t, this equilibrium point x star is stable equilibrium point, because this is also xt tends to x star with time. So here x star, equilibrium point x star, is stable equilibrium point. Case 2, if modulus of a is greater than 1, that is a is less than minus 1 or a is greater than 1, then xt tends to plus infinity or minus infinity according as a is minus less than minus 1, then xt tends to minus infinity. If a is greater than 1, xt tends to plus infinity. So solution diverges and the equilibrium point x star is said to be unstable. Case 3, if a equal to 1, then the system becomes xt plus 1 equal to xt plus b. Then the solution xt equal to x0 plus bt. So this t tends to infinity limit xt equal to x0 plus bt. This tends to obviously either plus minus infinity according as the value of b either positive or negative. This tends to plus or minus infinity. So solution diverges and the equilibrium is unstable when a equal to 1. Now the question from 2020 university question: a drug is administered every 6 hours. Let Dn be the amount of drug in the blood system of nth interval. The body eliminates a certain fraction p of the drug during each time interval. If the initial blood administered is d0, find Dn and limit n tends to infinity Dn. Consider the first order non-homogeneous difference equation here. So xn plus 1 equal to axn plus b with initial condition xt0 equal to x0. This is the non-homogeneous first order difference equation where a, b and constant. Equation 1 can be solved successive iteration, put n equal to 0, n equal to 1, so and so on. So we get x1 equal to this and x2 equal to this, a square x0 plus ab plus b, and x3 equal to a cube x0 plus a square b plus ab plus b. And so by induction we can find xp equal to e to the power p x0 plus summation e to the power p minus j minus 1 summation j equal to 0 to p minus 1 into b. So we get xp equal to e to the power p x0 plus p into e to the power p minus 1 by a minus 1 if a not equal to 1. Already we get this solution xt equal to e to the power t x0 plus b into e to the power t minus 1 by a minus 1 in the previous example. This is the solution. Xn equal to e to the power n x0 plus 1 minus e to the power n by 1 minus a into b. So same case here. So already we get this result, and we use this result a to the power p minus 1 and this plus 1 e to the power p minus 1 by a minus 1 when a is greater than 1. We considered the given problem. The first step is to write down the difference equation that relates the amount of drug in the patient blood system Dn plus 1 at the time of interval n plus 1 with Dn. The resulting equation is Dn plus 1 equal to 1 minus p Dn plus d0, where 0 less than p less than 1. So we consider the first order non-homogeneous equation for this for our problem. We get this Dn plus 1 is the present blood system Dn plus 1 at the time the interval n plus 1 with Dn, this Dn. So resulting equation is this. Using the formula, we get Dn equal to 1 minus p to the power n d0 plus d0 into 1 minus 1 bracket 1 minus p to the power n by p. Here a equal to 1 minus p and b equal to d0. This is d0 depending on time t0, initial time t0. So after simplification, we get bracket d0 minus d0 by p, bracket close, into 1 minus p to the power n plus d0 by p. Now 1 minus p whole to the power n tends to 0 as n tends to infinity. So obviously limit n tends to infinity dn tends to d0 by p, and this is the answer. Here, this d0 at the time t equal to 0, this d1 drug reliever at the time t equal to t1. So this d0, this d1 is equal to d0 plus 1 minus p into d0. So at the time t equal to n, this drug reliever is dn. So at time n plus 1, so drug reliever is this d 1 minus p dn plus d0 plus d0 plus 1 minus p into dn. So this is the, so d1 is this and d2 is this and so on is the problem. Now we define the equilibrium point, fixed point of the first order difference equation. Consider the difference equation xt plus 1 equal to axt plus b and discuss about the existence of equilibrium points for different values of a and b, under what condition the system will have a unique equilibrium point. Now, equilibrium point x star is said to be equilibrium point x star, or steady state, or critical point, or rest point, or fixed point, or stationary point, and of the difference equation xt plus 1 equal to f of xt comma t. T is time parameter. So here xt, if f of x star comma t equal to x star, that is we have put here xt plus 1 equal to xt equal to x star for equilibrium point x star. So consider the difference equation xt plus 1 equal to axt plus b. We say this right-hand expression axt plus b equal to fxt comma t. Say the equilibrium point x star of the value of xt for which x star equal to f x star comma t, that is this. So we get simplification x star equal to b by 1 minus a not equal to 1. If a equal to 1 and b not equal to 0, then there is no equilibrium. If a equal to 1, b not equal to 0. So numerator is non-zero, but denominator is 0. So it is undefined, so no equilibrium point. And the solution is the form xt equal to x0 plus bt. When b greater than 0, xt will increase, and when b less than 0, xt will decrease. If a equal to 1, b equal to 0, and then a equal to 1, b equal to 0, then the difference equation becomes xt plus 1 equal to xt, and this xt plus 1 equal to xt minus 1, and so on. So ultimately we get x0 equal to x1 equal to x2 equal to x3 and so on. And this shows that the initial value x0 is the equilibrium point x star, that is x star equal to x0, and condition of uniqueness of equilibrium point. And let x star be the equilibrium point of difference equation xt plus 1 equal to axt plus b is unique if and only if a not equal to 1. This is the condition for uniqueness of the equilibrium point x star. Now graphical representation of the equilibrium point, the x star is the actually graphical meaning of this x star equilibrium point x star is the intersecting point of the lines xt plus 1 equal to xt plus b and xt plus 1 equal to xt. We call this point is called diagonal passing through origin, and this is the reproduction curve xt plus 1 equal to axt plus b. So intersecting points with the reproduction curve and the diagonal are the equilibrium points of the system. Now case 1, if a not equal to 1 and b not equal to 0, and a not equal to 1 and b not equal to 0, then xt plus 1 equal to xt is the diagonal passing through the origin. Actually put here xt plus 1 equal to y and xt equal to x. So put here xt is the horizontal axis is x, and consider this vertical axis xt plus 1 equal to y. So this line is y equal to x. So passing through origin is the with angle is at positive x-axis is 45 degree passing through origin, and this xt plus 1, that is y equal to ax plus b. So y equal to ax plus b. So B is the y-intercept and n is the slope of this line. So B is the y-intercept and this is the slope of the line. So obviously the intersecting points with the reproduction curve and the diagonal is this point, and the x-coordinate, that is x star, is the x star is the equilibrium point of the system. So we get non-zero unique equilibrium point x star of the difference equation xt plus 1 equal to axt plus b, when a not equal to 1 and b not equal to 0. If a not equal to 1 but b equal to 0, so when b equal to 0, this difference equation is the uh, mm, straight line passing through origin. Here diagonal is the slope is 1, so 45 degree. So this slope is depends on a. If a is greater than 1, so this slope is greater than 1. When a is greater than 1, so this line is this line, and this diagonal is this line. So we get the trivial equilibrium point x star equal to 0, that is origin is the trivial equilibrium point. If a equal to 1, b not equal to 0, a equal to 1 but b not equal to 0, a equal to 1, b not equal to 0, so y equal to x plus b. Here y equal to x, so y equal to x plus b and y equal to x, these are two parallel straight line, one is passing through origin, other is this. There is these two straight lines are not intersecting, and so there is no equilibrium point. So equilibrium point does not exist for the case a equal to 1, b not equal to 0. And case 4, if a equal to 1, b equal to 0. So there, in this case, the two lines are identical. So there are infinite number of equilibrium points because two lines are coincident here. Any point on this line is an equilibrium point of the system. Next, come to the important theorem of this first order difference equation. By this theorem, we can say whether whether system exists an equilibrium point, is stable equilibrium point or unstable equilibrium point. Consider the system axn equal to a fxn, and x star is locally asymptotically stable equilibrium if modulus value of f dash x star is less than 1, and unstable equilibrium if modulus f dash x star is greater than 1. This in 2021 question, CU question. So consider this equation 1, and let's start with the equilibrium point of this equilibrium equation. So we put here xn plus 1 equal to xn equal to x star, and so put here x star equal to f x star, and now we study the stability of x star. So we put here small perturbation about x star. So xn equal to x star plus un. So actually un equal to xn minus x star is the small perturbation about x star. Now using this value from 1, we get from 1 equation 1 xn plus 1 equal to fxn. So we put here x star plus un plus 1 equal to f of x star plus un. So by expansion, Taylor's expansion series, so we get f x star plus un f dash x star plus order of un square, and neglecting the second order and higher order terms due to the small perturbation, so we get f x star equal plus un f dash x star, neglecting un square and higher orders. Un is small. So this can cancel from cancel x star from both sides. So un plus 1 equal to un f dash x star. This equation 4 is known as linear approximation of the nonlinear equation 1. Here, this equation first order nonlinear difference equation because of uh, term fxn. We don't know actually the expression of fxn. It may be linear, non-linear. We assume here fxn is non-linear. So the this expression 4 is the actually this is un, here un plus 1. So here is un, power of un is 1, here power of un plus 1 is 1. So actually this is the, and this is the extra is fixed value, so f dash extra is fixed value, so this is the linear equation. So this is the linear approximation of the nonlinear first order difference equation Axn plus 1 equal to Fxn. Now, if the initial value x0 is sufficiently close to x star, then the nature of ut is determined by the equation 4. So clearly, f dash x equal to un plus 1 by un. So modulus value of f dash x star is equal to modulus value of un by un plus 1. Now, if modulus f dash x star is greater than 1, that is un plus 1 modulus un plus 1 is greater than modulus un. So un, obviously, un is small. Magnitude of un is small. So un will not approach to 0. Un plus 1, un plus 2, with increases of n, un plus 1, magnitude of un plus 1 is higher, greater. So un will not approach to 0, and consequently xn will not approach x star, and therefore xn will move away from the equilibrium point x star as the time increases, and x star is said to be an unstable equilibrium. Case 2, if modulus of f dash x star is less than 1, then obviously modulus of un plus 1 is less than modulus of un. So un plus 1, un plus 2, un plus 3, and modulus value of these are all approaches to 0. And so xn will approach to x star equilibrium point. So x star will said to be a stable equilibrium point. Note that there is exponential convergence if 0 less than mod if dash x is less than 1, and oscillatory convergence if minus 1 less than if dash x 0 less than 0. These criteria are sufficient but not necessary. So if this condition hold, then x star is equilibrium point. This condition is sufficient. If this condition f dash x star is less than 1 modulus of f dash x star, or modulus of f dash x star greater than 1, then this is locally stable and this unstable for this. But we cannot say that when x star is locally stable, then does not imply a mod of f dash x star is less than 1. So it is the sufficient condition, not necessary condition for this. Here, MCQ question, equilibrium point of the difference equation xt plus 1 equal to alpha xt plus beta, alpha not equal to 1, is stable if modulus of alpha is greater than 1, modulus alpha less than 1, modulus alpha not equal to 0, and none of these. Here, alpha is less than 1. Alpha is less than 1 is the answer 2. Because if we put xt plus 1 equal to xt equal to x star for equilibrium point, so from the given equation x star equal to alpha x star plus beta, so x star equal to beta by 1 minus alpha, this is the equilibrium point. Now put this right hand expression fx equal to alpha x plus beta. So find f dash x equal to alpha. So f dash x equal to alpha, and this modulus of f dash x less than 1, then the system is stable. So modulus of f dash x means alpha, so modulus of alpha is less than 1, then the system is stable equilibrium point. X star is stable equilibrium point. Thank you. We conclude today's lecture.